Hey guys, we're doing section 5.8 inverses today, and to be totally honest, I wasn't planning on making a video for this lesson, but I was looking through the notes tonight. The lesson is kind of long and pretty boring, and I did not want to have to do this all together on a Friday. So I want to get the easy, boring stuff out of the way, so just kind of, deep breath, fill in your notes packet, let's get all this like vocab and lingo and methodology and stuff out of the way, the boring stuff that you can do, just fill in your notes packet. There's a couple hard things that we need to do in class tomorrow, so just keep that in mind that we're going to power through this first part of the video, and then I'm going to do some of the hard stuff in class tomorrow, so it's important that you understand the basics before we can apply it. Okay, so as a warm-up, we're doing first multiplication. It says find the product of AB and then find the product of BA. And be super careful because actually they are not the same. They're totally different. A times B does not have the normal multiplication rule of, the commutative property where they're able to move around and you can do BA and AB and they equal the same thing. Not the same thing here. Let's talk about why that is. So I'm going to first do AB. And so remember what we're doing is we're always going across down. So I'm doing the first number times the first number, which is 20 plus -1 times 0 is 0. That's going to give me 20. Now I'm going to go across and down the second column, across, down. So first number times first number is 16 plus -1 times -2 is 2. 16 plus 2 is 18. Now I'm going to go across down the bottom row, first column. -3 times 5 is -15 plus 0, so we get -15. And then last thing, bottom row, second column, so -3 times 4 is -12 plus -4. -12 plus -4 is -16. So this is my product for AB. Then the second part says find the product of BA. So I'm actually going to rewrite these. And I'm going to put B first, which is 5, 4, 0, -2. B is here. A is here. So B times A, I'm going to rewrite them so I don't get confused because I remember I always have to go across down. So I'm going to go across down, and this is going to be 20 plus -12. 20 plus -12 is 8. Then I'm going to go across down, so -5 plus 8, that's 3. And you can already tell this matrix is totally not the same as this one. Now let's go across, down, bottom row, first column. This is going to be 0 plus 6, so 6. And then across, down, 0 times -1 is 0, plus -2 times 2 is -4. So 0 plus -4 is -4. So totally not the same. So just beware of that when you multiply matrices. The order that they're in actually is super, super important. Let's talk about identity matrices. It's kind of like 1 for a matrix. So like when you multiply by 1, it doesn't change the number. Well, if you multiply any matrix by its identity, it doesn't change the number. So this is kind of weird. But just keep in mind that, remember when we did Gauss-Jordan and we talked about what winning looked like? It looked like this. That's actually the identity matrix. It should look familiar. And there's a application that we're going to do in order to answer the question, are these matrices inverses? And again, don't be too hung up on what's an inverse of a matrix, why do we have it, what is it, what do we do with it. Right now, just focus on how to find it and answer the questions about inverses. And then later on in the chapter, we're going to apply it. And same thing with determinants. Why do we have determinants? Why do we have inverses? Those questions are going to be answered later. So to answer the question of inverses, it's a yes or no question, and when you do A, B, it's supposed to equal 1, 0, 0, 1. And it has to work for both. When you do BA, it's supposed to equal 1, 0, 0, 1. Oops, that's a 1. Okay, that's what it's supposed to look like if they are inverses. So I'm first going to do AB, just like we did in the warm-up. And remember, keep in mind we're going across, down for each element. So I'm going to do -2 or 2 times -1 plus 3 times 1. That gives me 1. Good. That's what I wanted. Keep in mind this is what I need if they are inverses. And if I ever get a number that's not what it's supposed to be right here, then I'm just going to stop. I'm not going to continue the whole problem. Now I'm going to go across down for the second column. 2 times 3 is 6, plus 3 times negative 2 is negative 6. That gives me 0. Now I'm going to go across down. This is going to be negative 1 plus 1, which is 0. And I'm going to go across down. So 1 times 3 is 3, plus negative 2 is 1. Okay, now I have to do BA. And for BA, I'm actually just going to write A right next to B so that I don't get confused, because it is confusing when they're not lined up in the right order. So I'm just going to do BA and do it this way. All I did is I copied this right here so that they were lined up in BA form. So I'm going across down. So I have negative 2 plus 3, which is 1. That's good. I'm going to go across down again. So negative 3 plus 3, which is 0. And I'm going to go across down. So I have 2 plus negative 2, 0. And across down. So 3 plus negative 2, which is 1. So yes, because both AB and BA, when you multiply them, you get the identity matrix. That's what this is called. That means that yes, they are inverses. Okay, I'm going to work out the second one. I would like you to try it. See if these two are inverses. Remember, you have to check C times D and D times C. I'm going to pause the video and work it out just so you can check your answer. Okay, so that was actually really simple. It took me 3 seconds to pause the video and do the work. So let's talk about how I got negative 1 here and why I ended up with no. So first thing I did is C times D, which means across and down. So that means I'm doing negative 1 times negative 5, which is, I'll actually write it so you can kind of see, just in case you're a little confused. Negative 1 times negative 5, which is 5, plus, and then 2 times negative 3 is negative 6. So in that space, gave me negative 1. And remember, it's supposed to be 1, 0, 0, 1. So the first time you get a number that is not one of these, where it's supposed to be, you can stop. The answer is no, they're not going to be inverses. So the fact that this was a negative 1, it was supposed to be a positive 1, that means we're done. We're moving on to the next question. Okay, a little bit more in terms of inverses. How do you find the inverse? So difference between that question and this one. This question is, are they inverses? Now we're actually given a matrix and we have to find the inverse. So all of your steps are written up here in order, right, as an augmented matrix with A on the left and the identity matrix on the right. This looks weird, but I'm going to do it. So instead of recopying this matrix, I'm just going to put a bar here. And I'm going to put the identity matrix on the right, like it said to. Okay, that's step 1. Now what we have to do is GJ. And I know it's a little bit annoying, but I'm going to show you a shortcut in just a second. Heads up, it's coming. But to do GJ, that means that what we're looking for is we're trying to get winning on the left. So we're trying to like multiply this by something so it cancels this, turn this into a 1, use this to cancel this, so that we have the identity on the left and then our answer is going to be on the right, just like we did when we were solving systems of equations. So what I'm going to do first in order to do GJ for this is I'm thinking, what do I have to multiply this by so it cancels this? And that would be negative 2. And so when I do that, my top row isn't changing. My bottom row becomes 0, 2, negative 2, and 1. So now I need to take half of this entire row. So again, top row isn't changing. I'm kind of running out of room here, so I'm going to write a little bit smaller. When I take half of the bottom row, I get negative 1 and 1/2. And then all I have to do is use the 1 to cancel this, which means I just need to add the two rows together. So I need to add row 2 plus row 1, and I'm putting it into row 1. That means bottom row isn't changing. And I have a 1. When I add 1 plus negative 1, that's 0. Negative 1 plus 1 is 0. 1/2 plus 0 is 1/2. So that means that this is the inverse of the original problem. Those are inverses. So what I could do is I could check and I could multiply this by this just to make sure that it gave me the identity matrix, but that's one way to find it. Okay, so let me show you a shortcut real quick and then we'll be finished. So the good news is, what I wrote in the box over here is that, yeah, we've already done GJ before, so you should be familiar with this process. It's just a few more numbers added into the mix. But the good news is that there's a shortcut, and there's kind of a formula. Here's your formula. If here is your matrix, to find the inverse, you find the determinant, and then all you do is you switch A and D. So see how those switched? And then you make C and B negative. So those two numbers become negative. And so what I want to do is I'm going to show you how to find the inverse using the shortcut for numbers 1 and 2, and then we're going to be done. I'll probably verify the fact that this could also be found using the shortcut as well, but there's two different options of how to find the inverse. You can do GJ like we just did, or you could use this shortcut. Keep in mind, here's our formula to find the inverse. So the first thing I have to do is find the determinant and then do 1 over that number. So I'm going to do that first. For number 1, I need to first find the determinant. So remember, when you do that, you start by going down. So I'm doing 4 minus 6. So that's negative 2. So I'm going to do 1 over the determinant. So keep in mind, this number goes here. It's part of the formula. And then in my matrix, what I'm doing is I'm switching these two numbers. I'm just going to literally flip-flop them. So I'm writing 4 here and 1 here. And what happens to these two numbers is they just become negative. They stay where they are, but you make them the opposite sign of whatever they are. So I'm going to make it a negative 2 and a negative 3. So now all I have to do is distribute that negative 1/2 in to each of these 4 numbers, and then we're done. So when I do negative 1/2 of 4, that gives me a negative 2 here. Negative half of negative 2, that gives me a 1. Negative half of negative 3 gives me 3 over 2. Negative half times 1 is negative 1/2. So this is the inverse. It's very quick, but if you're a fan of GJ, then you can also use that method. Let's do one more to make sure we're cool. Let's first find the determinant. So again, we're going to start by going down. So 3 times 2 is 6. Minus, and then when you go up, 6 times 1 is also 6, which is 0. And so that means I'm doing 1 over 0. Wait a second. I'm not allowed to divide by 0. So here's something really important, you guys. If the determinant equals 0, the inverse does not exist. That would mean you would run into a problem if you were doing GJ. You can't do the inverse when you don't have a determinant. There is no inverse for this matrix. So that's something super important that we ended on. Just make sure that you've got that part down. If the determinant is 0, there is no inverse. A mathematical way to write that is the inverse does not exist. Let me just show you the shortcut for this one that we did GJ on. Because keep in mind, we got an answer here. We got an inverse. What I'm going to do first, or I'm going to do the shortcut, just to make sure that we got the right answer here when we did our GJ. So I'm using this matrix. I'm going to first do the determinant, and remember, you have to do 1 over the determinant. So the determinant of this matrix is 0 minus negative 2, which is positive 2. So 1/2. And then remember, these two numbers switch, so that becomes 0 and 1 instead of 1 and 0. And these two numbers stay where they are, they just become the opposite sign of whatever they are. So that's going to be a positive 1, this is going to be a negative 2. So 1, negative 2. And then just distribute the 1/2 in. So I get 0, 1/2, negative 1, 1/2. And boom, shakalaka. That's the same exact answer. So you can do GJ, you can do the shortcut, you guys. What we're going to do in class tomorrow is we're going to do a big one using GJ because, like I said, the bad news up here is that the shortcut only works for 2x2s. Bad news is that you have to do GJ for this. I'm also going to show you a second method on how to find a inverse of a 3x3s because GJ sucks, some of us hate it. I'm going to show you another way to do it that you have the option of using whichever one you want. Thanks for watching, you guys. I know this is some tough stuff that we're doing right now in class, but bring your questions to class tomorrow, and it's going to be a much shorter lesson than having to do all of this all at once tomorrow. So I think it's going to be better. Bring your questions, and I'll see you tomorrow.